Okay, today is 5.3. We are writing equations in a completely new form today, the point-slope form. We've always been using the slope-intercept form because we needed the slope and the intercept. Point-slope form needs a point and the slope, and that's it. So this is the form for point-slope form. We take the value y and we subtract the y coordinate from the point. And that equals the slope times, and in parentheses, x minus the x coordinate from the ordered pair. So point slope form needs a point and a slope, where we take the y and subtract the y coordinate from the point, and that equals the slope times, and in parentheses, x minus the x coordinate. So let's take a look at how this looks. Now, if you notice, the direction is exactly the same from 5.2, where we're going to write an equation of a line, but we're going to write it in point-slope form. Be very, very careful that you do the form it asks. So we've got the point 3, 2, where in this ordered pair, the x coordinate is 3, the y coordinate is 2, and the slope is 2. There's your m. My point slope form is the variable y minus the y coordinate. Well, the y coordinate in my ordered pair is 2, so it's y minus 2. And that equals m, the slope, which they told us is 2, and that equals x minus the x coordinate, which is 3. This is your answer. The y minus the y coordinate 2 equals the slope of 2 times x minus the x coordinate, which is 3. That is in point slope form. So you can see it without craziness. This would be point slope form. We have the y minus the y coordinate equals slope times the x minus the x coordinate. Now, we can graph equations from point slope form because they've given us a point and they've given us slope. That's why it's called that. But if you look at the equation, can you find the point and the slope that they gave us? Well, that 2 represents the y coordinate, not the x, y minus y1. So I know that my ordered pair, the y coordinate is 2. And that equals 1/2. Well, that 1/2 is my slope. So far, so good. Minus x, or times x minus the x coordinate. So I know my ordered pair is 2, 2, and I know it has a slope of 1/2. We can graph this by plotting my point 2, 2 first, and then from my point, I count my slope. Up 1 over 2, up 1 over 2, and you now have a line. Not as easy as slope-intercept form, but they gave you a point and gave you slope. Now it is always y minus the y2 and x minus the x2, so watch the signs of your values. So if they give you the point of -3, 5, there's my x, there's my y, and my slope of 4. When I do my point slope form, that's y minus 5, because that's my y coordinate, equals 4 times x minus, what do I write when it's minus -3? Well, minus -3 means plus 3. That's how I would show that it is a negative value. And there's my point slope form. So if I look at my checkpoint number 2, if I'm going to graph it, my y coordinate is actually -1. My slope is 2, and my x coordinate, because it's a subtraction problem, is just 1. So my ordered pair is actually 1, -1, and my slope is 2. Up 2 over 1. Now notice I didn't start on the y-axis. You shouldn't. You should start at the point that they gave you in the point slope form. And the point they gave me was 1, -2, because 1 from the x, -1 from the y, and my slope of 2. Now, if we're going to write an equation of a line in point slope form when the line is shown to us, we need 2 things. We need a point, and we need the slope. That's why it's called point slope form. Well, we've got points. Now we need slope. You can calculate slope using your 2 points. So -3 minus 2, -2 minus 4, which gives you the fraction of 5/6. Let's make sure of that on our picture. 3, 4, 5. 1, 2, 3, 4, 5, 6. You bet. My slope is 5/6. Now, because you have 2 points, you've got 2 different options for point slope form. You can choose either point to write your answer. Let me show you how both of them actually work. If you use the point -2, -3, your point slope form would look like y plus 3 equals 5/6 times x plus 2. Notice that I've changed those to plus because my coordinates were negative. If you use the ordered pair for 2, you have y minus 2 equals my same slope, 5/6, times x minus 4. Those are your 2 different answers. I would take either if this were a quiz or a test and I asked you to write it in point slope form. So either one of those would be fine. Let's prove that they're the exact same line. And we're going to prove that they're the same line by putting them actually into slope-intercept form. And slope-intercept form has y by itself. So let's check this out. If I've got y plus 3 in the first example I did, I need to be able to subtract it. But to do that, I need to distribute that 5/6. So I'd have 5/6x plus 2 times 5/6 is actually going to give me 5/3 minus 3. Oh, this is not going to be pretty. Y equals, well, 5/3 is 1 2/3. And if I subtract 3 from that, that is negative 2 1/3. Yeah, negative 2 1/3. So my slope is 5/6. My y-intercept is negative 2 1/3. Not pretty, but let's see what I get over here. So if I distribute the 5/6 over here, I get minus 26, which would be 10/3. Yep, which this value 10/3 is 3 1/3. So let's go ahead and write it as 3 1/3 plus 2 . I don't know how much you guys have seen. I have cut because guess what I figured out? When I add 2 to both sides, I'm going to get y equals 5/6x, and that's actually only going to give me negative 1 1/3. That means that these are different, or Ms. Kern's math is off because she tried to do it in her head. Epic fail. You guys know better. When I take 1 minus, or 3 minus 2 1/3, I know I'm going to get a negative answer. But I should have worked this out. I apologize, guys. This does give you 1 1/3. So we actually do have the same equation, even though they are nasty and in bad fraction form. I apologize. They really are the same. And I get them to be y by itself to prove that they're exactly the same. But in point slope form, either of those red problems would be correct. Now, to do this in a story problem, we need to figure out what is the point and what is the slope. So you need to know slope, which is the rate of change, and you need to know one pair of input and output. So let's look at our story. During the period 1990 to 2010, a gallon of milk increased 5 cents per year. Well, I see 5 cents per year. There's my slope. Okay. In 1995, the cost of a gallon of milk was $2. That looks like an ordered pair for me. So something about 1995 and $2. Now we're going to write an equation that gives the total cost C as a function of the number of years. So that means my years is my input, and my output is the cost. But do you notice that it says years since 1990? That means that 1990 is the beginning year. It's year 0. So years since 1990. If you have this time frame, 1990 to year 2010, 1990 was the beginning year. 2010 would have been 30 years later. So we're talking about a 30-year difference from 1980 to 2010. So from year 0 to year 30. That means that my years can only go from 0 to 30. Now, if 1995 is my year, how many years is that after 1980? Well, it's 15 years. So 15 is actually my input value because 1995 is 15 years after the start of this, and it was $2. So my slope is 5 cents per year, and my point is 15 years, it was $2. So I'm going to write this in point slope form. Sorry, I jumped ahead. I guess I do want to write it here. Y minus, well, my y value is 2. My slope is 0.05. My x minus 15. There's my point slope form. So here's my equation again. Now, we've plugged in my value for slope and plugged in my x-coordinate and my y-coordinate to write it into point slope form. Now that I have that equation, I can find the cost of a gallon of milk in year 2000. Well, 1980 is year 0. 2010 is year 30. So 2000 is year 20. So when I go to plug this in, y minus 2.05 times 20 minus 15. 0.05 times 5. And this is 0.25. Oops, space. So in year 2000, the price of a gallon of milk was $2.25, which makes sense because it increased 5 cents per year, and in 1995 it was $2. So then it raised 5 cents every year to get you $2.25. So every time you're looking at your story, where's your ordered pair and where is your slope? Now, if they didn't give you slope, we might have to calculate it. So the table shows the cost of renting a canoe for different times in hours. Can this situation be modeled by a linear equation? Well, let's find out. Questions to ask yourself. What is the input and what is the output? Well, they gave you a table. Well, our time is almost always our input, and our cost is almost always the output. Is there a constant rate of change? That means, is there a constant slope? So, my change in y is $10, and my change in x is 2. That means a rate of change of $5 per hour. Let's see if that works. Is there always a change of 10 and a change of 2 hours? Yes, there is. So everything jumped by 2 here and everything jumped by 10 here. That is a constant rate of change. So yes, there's a rate of change, and it is $5 per hour. I should always use my labels. It's $5 per hour. Is this a direct variation? Well, as the hours doubled, 22 to 32, that did not double. It changed by a rate of $5 per hour, but 1 hour doesn't mean $5. We actually had a different starting point for this equation. So that means there is a b in this equation. So I can write this in my point slope form because I don't need to calculate b. I have my slope and I have a point. You can choose any point from here. So my equation can be y minus 22 equals 5 times x minus 2. There is your equation in linear form. So you don't have b, but you don't need it. You can write it in point slope form because you have a point and you have a slope value. So ta-da. And here is your homework for 5.3.